Hey there guys, and welcome back. So today we are doing those capacitive touch sensors for the arcade stick. We had done these prototypes, which actually, you know what, since I got the camera on, there we go, had them within reach. These guys, if you recall them, we will not be using the big guy, although the big guy does work as demonstrated. We will be making, I think, about this small. We may be able to get this a little bit smaller and it'd still be usable, but this is probably pretty close to it. It'll only be maybe a millimeter or two smaller if we wanted to do that, and I'm not even sure it's worth, attempting. So we'll probably just make them about this big as this test piece and go from there. So in terms of what we're making, my idea for this is to get our extrusion and do a bridge basically. So this is extrusion on each side. And then let me turn down the light a little bit to try to get some more, because today it's pretty glary, it looks like. Yeah, a bit better. Turn this guy down. Yeah, that guy doesn't impact as much. All right, that's where we're at right now. So, got our extrusion, and I'm thinking we're gonna attach, I think, on the inside. I know that sounds a little counterintuitive, but I'm thinking this whole entire thing is going to be assembled upside down to begin with. So we'll probably put our attachment points on the inside, and on the top we're going to have attachment points for whatever we put over top. So you'll recall that my idea was that we'd have actually, let me go ahead and get it. Stuff I didn't think I'd need for today's stream. Original idea was using some transparent plastic. I don't think this is going to actually happen now. I think I'll just go for regular paper at this point. The idea behind using the transparent plastic was because we were doing resistive originally, so I was going to use this instead, but that's not happening now. So it's probably just going to be regular paper, just print out whatever we want to display. And then underneath the paper, so the paper gets attached up here on top of the extrusion. That's why I want to anchor from the inside. We could also anchor from the outside, which is reasonable. It's just extra plastic. We just print some extra plastic, wrap around the outside of the extrusion, and then we're there. Otherwise, we're going to bridge across here, as I believe I started to say, and this bridge is going to have a hollow point throughout it. And I want to put little inserts. So these rings, basically, I don't see any reason why they can't be square. So we'll just make square inserts. And the square inserts will just sit in a tray. Basically, it acts as a tray. And we can position them where they want. And then, it'll raise across this way. And then we can just duplicate these bridges all the way down to get more levels. Obviously, this particular design does not allow, to some degree, does not allow complete freedom of placement of these guys. But again, this is arcade prototype. There we go. I tried combining arcade and prototype into archetype, and that is not the correct word. This is although it kind of is. I mean, it works, right? In archetype, it's the archetypal controller. But regardless, this is a prototype controller, so if I wanted to do something funky like this, where the holes were in random spots like this, maybe you can't quite get that layout, this layout over here on this, but you can get it close enough. And then one of those things, if you wanted to make a final version, you just print it out exactly, or cut it out, depending on the material that you want to use, exactly like this. And you can always take these guys and just stick them up underneath, just glue them basically to the finished plate that you're using, this finished panel, I should call it, and then you'd be good. So that is the plan. So again, it's going to be a tray these guys sit in. One place that I'm kind of not sure how exactly I want to do is how these guys attach to the tray, because you don't want these guys sliding back and forth inside of the tray. And Let's see. Yeah, okay, so it is not just the one arm that's making this glare up, so that's unfortunate. Actually, does that mean that my auto, let's see, video input? No, I don't have any of the, like I don't have white balance or brightness on auto or contrast, so that shouldn't actually be doing that. Interesting, because that's not, oh, exposure? That may be due to exposure being on auto. Okay, there we go. Looks like it is no longer brightening up the screen. So, that's where we're at right now. But, as I was saying, sorry, sidetracked. So, if we look at this tray from the side, what I think I'm doing is I'll countersink nuts here on the top. So, this is the top right here, and this is the bottom. And then these, you'll recall I said I think this is getting assembled upside down, right? So then our little trays would be T-shaped like this, and then they would screw into these side tracks. So this also turned, in case you can't see that, this way. So we turned this tray sideways so that we can see these are the two rails right here. These are the two rails. This is the open spot right here, so this is actually a hole right here. And then our ring slash square ring just gets nuts right there and there. That's how I think I'm doing it. We'll see how it turns out. So over to Fusione. I've got this guy open in Fusion just so that I can get sizes, which we got this at, what's the inside diameter? That's the more important thing. Inside diameter is 28 millimeters. So again, we could maybe go down to 25 millimeters, just make it a solid inch-ish. We'll see what happens. We'll see what happens. Otherwise, I also got the base setup ready to go because that is mundane, tedious work. So we will go from here. And does the base actually have a top of extrusion? Nope, it does not. So we will use that. And we will call this... Actually, I would like to make a tray. I would like to make the trays and the sensors separate. So, tray. And hop in here. Whoops, that is not correct. Let me turn these guys off so I don't do that again. And I can turn the origin off now because I don't need it. Actually, let us, I take it back. Come in here, and I am confuzzled. There we go. That should be the outside. Due to the origin. There we go. Just to get my out. Alright, now we can go back to the top. And we actually, I just realized, aren't oriented the correct direction, although it doesn't necessarily matter. You could orient it either direction, because again, how the paper looks on top that's covering this up will determine how it looks like to the person using it. So it doesn't necessarily matter that we oriented it in the wrong direction, or if you even assemble it in the wrong direction, because all that matters is what the player is using. So now the origin is off. My sketch origin is all the way over here for whatever reason, but that's okay. I guess that's center to the, let's see. No, that's not even center to the extrusion, so that's cool. That's cool. Actually. I forgot, I also need the inside of the extrusions because we need to do the attachment points. There we go. Toss this in here. And let's see. So the rails actually do need, if we're going to do the captured nuts in the rails, which makes more sense than the bolt. So actually, let me just hop over here and demonstrate that. So I did capture nuts here because you figure if this is the rails here and this is our T-shaped ring here, if we do bolt heads on top, then we gotta, you know, they can't actually be there. They'd have to be countersinked anyway. So it's about the same size, and we're assuming that we're going to be assembling this upside down anyway, in which case we don't want to be screwing the bolts down upside down. So that's the logic there, just to clarify. So back to what we were doing. Get this guy lined up. There, and that's correct. What I was actually trying to figure out is how big this actually needs to be, because I made these guys 50 millimeters, figuring that was more than enough space, but that may not actually be the case, because we figure that the inside of the tray, if we come back over here, so this is going to be an inside tray, we have 38, about 39 minus 28, so we have about 10 millimeters of material just to house the wire. So if we have 10 millimeters of material to house the wire, and we want, well, actually we can just go ahead with that 40, I guess. Yeah, we can just go ahead and call this 40, just round numbers. So if we got this 40 here, we might actually have enough no, it's gonna be real close. We don't have enough wall thickness. Okay, there we go. So that is the outside diameter of the trays, the T trays. And then this, do this, do this, and actually, let me kill these. Kill that. I'm gonna redesign this a little bit. And kill that. We'll go around the outside. We will go around the outside here. And this guy will be centered on here. There we go. And you just need to be swapped down to the bottom as well. Yeah. And doing this because obviously this is the easier way to do the outside diameter. So we know we need capture nut points over here, and if we're using M3s, that's 5.45. Toss it there. This actually all is construction lines for general purposes. That's 3 millimeters here for my wall thickness, is what I like. And then we quinky dink that and tangent that and that. I'll go ahead and also tangent the top side just to keep it in place. And I guess we will get you parallel to that. There we go. So that's what we're looking at. So now the out to out is 65. So again, recall how I was saying it depends how big everything ends up, whether or not you be able to get fine control over where the hole placement is. At this point, we're at 1.5 inches-ish, about 65, about 1.5 inches-ish. So you won't be able to have, plus the holes are inset by, I think this ends up being, let's see, 3 and 5 and 3 is 11. Yeah, so about 1/2 inch. So you have actually a full inch between trays right now, which is a bit unfortunate. Let's see. Is there anything we can do about that? The only thing we could do about that is actually to delete this, toss this in here. That one. Okay. And then grab that guy and do this. So instead of having T-trays, just having the attached on one side, the capacitive sensors attached on one side. That is a little flimsy, but it may actually not be bad enough, because we're not actually supposed to be slamming on these capacitive sensors. We're not supposed to touch them at all, really. So there's not necessarily a chance that it will break, and that does save us a full 1/2 inch on each iteration. So just to demonstrate, I don't normally do this in sketches, but we'll do it for the sake of demonstration purposes. So this is how it will be stacked now, right? Just imagine this lined up perfectly here. So now you T-nut on this left-hand side, and the right-hand side is a little supported just because of tightness on this guy, depending on how tight you get. Otherwise, if this guy, because this tray does not necessarily have to be here, this tray could be over here. You could have this bigger gap depending on how your layout works on your input. So, one of those things in this scenario where you're actually this far over, then it would be better to have rails on both sides for the T-nuts to, I'm calling them T-nuts, but the capacitive sensors to attach to on each side. However, in this situation, by not having the bottom side, you save a full 1/2 inch on each of these. And let's say you have 5 of these, so that's a good 2.5 inches, which is, you know, a decent amount. It's not negligible. So, I guess we could do both. We could design for both. That's definitely a possibility. Alright, we will design both. I don't see a reason why we shouldn't. Let's see. The one other thing now that I'm thinking about this is because these need to be adjustable, and I did not consider this beforehand, but this is going to have to be a slot all the way down this edge, which we can do. It's just, again, had not anticipated. So, I guess I should, let's see. I'm going to take this back really quick. Actually, you know what? I'm not going to take that back. I'm not going to take that back. I'm going to change my mind and take this one back. So, we are going to go ahead and mount from the outside. I have decided. So that will just be 3. Actually, I think I normally make these 4, don't I? It's been a little while. I think I actually make the mounting side 4. So we'll do that. Boom. Alright, alright. So now, I'm going to back up a sec. Take a step backwards, and we're going to do actually the inserts first. Insert. Capacitive insert. Because that will tell me, so I could actually just math it out, right? If we come here, I could say, okay, my capacitive insert is going to be about yay big. It's going to have about this much overlay, so therefore this slot needs to start, you know, this far down. That's what I'm trying to do right now, is I'm trying to get that slot, figure out where that slot is at. That's why I'm taking a detour right now. Actually, the alternative argument is that the slot doesn't, you know, we don't need to be absolutely perfect with this slot. This slot honestly could just go from the very edge of the extrusion, even though it will not be used. So the bolt will actually start roundabout where it's at right now, let's say. So that's fine. Yeah, we can just do that. Keep it simple. Just keep it simple. Alright, there, and there. So we just do that. And now we can go ahead and extrude. So this will extrude up. Let me extrude it up 3. Yeah. And we're going to come back in here into the sketch. So, and I'm going to call this single-sided tray, actually. And let me, actually, yeah, so single-sided trays, the capacitive insert would not, you wouldn't bother with a flange on the other side for the capacitive insert, because that's just wasted plastic, and it actually would get in the way. It wouldn't, yeah, it could get in the way. It could get in the way. So, we will go ahead and leave this. I was thinking about deleting this, but we'll have 2 different types. We'll have capacitive inserts one-sided or single-sided, whichever you want to say, and those go with the single-sided tray, and then we'll have the other ones that are double-sided. Okay, so I was coming back in here, and throwing this in. And then throwing this in. And, no, actually, I take it back. We don't need that one. We can just do this and toss in another slot in here. Again, this can be there. These want to be tangent to this hole. And that can go ahead and come all the way down here. And this is the hole for the bolt to come through. Finish. Alright, so this is tray top. Rename tray top. And then this extrusion that we just created will be down to actually, let me just go down an arbitrary amount. Let me go down, let's say, -5. And the reason I'm doing an arbitrary, oh, actually, I take it back. I take it back, I take it back, I take it back. Yeah, we're gonna go all the way back here and undo that because I just realized there's extra stuff I got to add here. So we will start a new sketch, and this is that was top of extrusion. Yeah, I can't really call it bottom of tray. I could call it bottom of tray lip, but top of extrusion makes more sense. We will go ahead and grab that just as a reference circle. And let's see. Also grab that. Yeah. Guess so. No. Not that one. Let me grab that one instead. Okay, cool. And this is because this single side actually cannot overlap the extrusion. That's why we're doing this. So this is the tray strut, I guess I'll call it. And turn that guy off. Turn these guys on. Let's see. This is, yeah, this is going to be solid. And let us see. I'm trying to think if there's any reason not to line this up with the top, if to offset it. I can't think of any at the moment, so we'll just do that. Do that. So that is my inside hole, and I do actually need derp this side and that side. I do need those two because I need to know where to go to. Makes sense? Yeah, I think that makes sense. Okay. So this is going What happened? Oh. I exited the sketch. That's what happened. There we go. This guy can be that for right now. And we will go ahead and collinear that, and I should have also pulled in the inside. I also do need the inside. So project that. All right, there we go. There's our strut. And where's my bodies at? Oh, I accidentally did this before the bodies. There we go. Down, extrude. Extrude, please. There we go. Turn the body off. Grab those. Turn the body back on. -5. There we go. There we go. So hopefully this stiffens up the this thing a little bit, is the hope. because obviously that's super squishy with just the 3mm on top. So hopefully this stiffens that up a little bit. We also... Is that right? That does not look right, does it? Oh! That's what I screwed up. Derp. A little bit of a derpy storm today. Whoopsies. This is supposed to be 3. I forgot to come in here and set that. And these are supposed to go coinkydink. There we go. I recall doing this originally, and then I went back and changed some things. I did that originally in the first sketch, and then forgot to bring it back in once I projected onto this sketch. So there we go. So the T-nut can slide along this thing to get lined up. Not the T-nut, the regular nut, the regular hex nut. The T-nuts go in the sides. So the hex nut can slide along that thing to get lined up with the bolt, and the bolt goes through the center there, and otherwise this is just providing some support along the length. So that is the single-sided one, and now we can start designing. No, let me add the attachment points. So we will, yeah, we can just keep on using top extrusion, that's fine. Project out these guys, and I already had 4mm allocated for the attachment points. So we will do this. Actually, yeah, I'm gonna mirror this across. All this stuff is on center, so I should be able to just mirror it across. There's that. There's that. And there's that. And extrude it. There is the components. We will extrude. Let's extrude to there. And then, oh, 2 objects. Come on, give me the face. There we go. And then an extra 4mm, -4. And that's a join. Okay, cool, cool, cool. And this still, well, this print's a little funny, right? Because we have this slot for the hex nut. So the slot for the hex nut is going to definitely need supports. It's not great, but it is what it is. And we'll come around to the outside. Outside front of tray. There we go. Project out the center point on here. Do that. Project out the wall. Do that. Toss in our center line actually first. So toss that to there. Try to get that right angled. Turn the bodies off so I don't have to look at them. Right angled. Grab the center point here. Make sure you pass through the center point. X. Circles. 4mm is what we're using for the mounting on the arcade stick. And yeah, I'll go ahead and do this the way I often do it, which is to put this connecting line in here, center it on there, and then define the distance between holes, which we'll just call 35 arbitrarily. There's that. Extrude this out. Bodies. Distance all. We'll just do distance all. And then we can go ahead and mirror those over as previously discussed. And features. Whoops, that is not features. Features. That guy and that guy over the mid plane or the origin plane. And there we go. Now we are done the tray, the single-sided tray. So we can go ahead and make, this was tray attachment and attachment holes. There we go. Attachment and attachment holes. And here we go, keeping organized. This is the bolt hole, bolt slot rather. There we go. All right, cool. Everything is organized. We'll just grab this really quick. All right. Beautiful, beautifully organized. And we will now make this a color. Plastic. Let's grab that one. No, I take it back. That's ugly. Plastic. Yeah, we'll go pink. That's fine. All right. I swear I lifted my mic up earlier, so apologies for any noises coming through the microphone when I just readjusted it. Could have swore I lifted it up earlier, and it seems like it might be drifting. The funny thing is that I know it doesn't drift like all the way down because I've sometimes after stream have just left it there in front of my face and went to bed, and it has not ended up on the floor afterwards, but it is what it is. Alright, capacitive insert. So we will just go ahead and make this wherever, because we can always align it later. Turn that body off. Actually, can we? Yeah, we kind of can. Okay, so we kind of can. We'll talk about it in a minute. I'll go ahead and get this. Center it up. We said 28 on the inside. Yeah, 28.5. I was just going to round that to 28 on the inside. And let's see. Do I want to make this square or rectangle? I guess we'll keep it square. I am not doing rings only yeah, we could do rings. Yeah, to be fair, we could do rings and then just make the outside square to sit in the tray. It's a possibility. I mean, technically speaking, even the outside doesn't need to be square. Again, technically. Just because, so long as it catches the bolt and has a flat bottom, it should be fine. Yeah, I feel like the circles are more natural. I also don't have to worry about 28. I don't have to worry about the wire. So wire going around the corner of the squares, gonna have to fillet that if we do squares, so that the wire actually can go around, because wire cannot take a 0-degree turn. So, or a 0 radius turn rather, not a 0-degree turn. All turns have degrees. Well, yeah, it's going straight. It's going straight should be not a turn. I believe that is not considered a turn going straight, so makes sense logically speaking. So. Let me go ahead and copy pasta this sketch here. Small ring. Oh, that's right. I went ahead and parameterized this. So, yeah. Okay. Yeah, let's actually instead. Yeah, derive is fine. Here, existing. This guy, include parameters. Oh, actually, I wonder if I can include in parameters without selecting the object. Arcade. This is where we at. Capacitive touch array. There we go. And did I get the... Oh, shoot. Finish sketch. I needed to do this beforehand. There we go. And now let's check if I got the parameters without bringing in the objects. Capacitive inserts, sketch. No, we did not. Oh no, that is this one. That is this one. Base height 20. So all I got was that then. Okay. Oh, that's right. You actually need to star stuff. That is right. There we go. Inside wall. Outside wall thickness. Okay. I believe that is everything I need. And we'll hit save. And I do have the editable documents available, so we don't have to fix that. We will get the new one. And now we will check. I do not see it. Okay, gotcha. I do not see it, which means... Oh, did I just close that? Am I a doofus? There we go. Actually, I didn't need to open that up, right? I can just double click here. There we go. Alright, cool. So there's that. And parameters are on favorites. So let's see if we get them now. And I will turn that off. Change parameters. Huh. Huh. So I just updated that one. And we have favorites selected. Huh. Cancel. Favorites are selected. Okay, let us try that from the beginning then, because I definitely do not see capacitive ring on this list. Okay. Let's delete that then. Try this again. This time I will make sure. Existing. We do have favorites selected. Capacitive, not capacitive ring. Capacitive touch array. Turn that off. Go to... Huh. Yeah, it's not even down here. Huh. Fascinating. Why can't I bring my parameters over? Why you do this to me? I didn't change parameters. Oh, wait. Huh? I didn't change parameters though. Close that. Open that. Modify parameters. Alright, I'm lost. They're gone. We do not get parameters. So, I guess that is that for that deal then. So we'll open that back up. Don't know why that appears to be broken, because I've done that before and it's worked before. So we will simply have to do this ourselves. Let me screenshot this right quick so that I don't have to keep on coming back over and checking. Change parameters. There's that. Screenshot. Alright, there we go. Alright, and we will now add our own parameters. So we have inside wall thickness 1.5 millimeters. Wire 22 gauge dia is 1.7. Small ring ID. This is in inches. I did this in inches, evidently. Although we were changing this, the ID we were changing to just 28. We were rounding to 28. So I will adjust that. And outside wall thickness 20, no, 2, not 22. There we go. Okay. So back to this guy and okay, good. I still have him. Wait, did I misspell that? Too many 2s. Okay. So I'm gonna delete this. We're gonna go inside. No. Small ring ID. There we go. There is that. This is inside wall. This is wire diameter. And this is outside diameter, or outside wall thickness. We can turn that solid because again, we're going to do this. Not that button, this button. There. Not there. There. There and there. Okay. So that should be everything I need. Finish. Now let me double check how I did this. I recall doing this torus here. How did I set that up? Profile. Okay, so I could select the sketch profile. Good. So how do we extrude this first then? We just went 5 millimeters up. Okay. Five millimeters up. And then the torus. Is the torus really that low? Where's my sketch at? Yeah, my sketch is on the bottom. The torus. Yeah, the torus is up a little bit. So, okay, this is the torus line. So, that's wire diameter in half plus 0.3 millimeters. So, torus offset. Torus offset. I'm gonna do that. I did say 0.3, right? Yeah, 0.3. Just sounds very small to me. That's all. Okay. So we do this minus wire 22 divided by 2. Or actually, yeah, that's fine. Not really fine. Plus 0.3. There we go. Okay, cool. So now we go on the torus on that plane, and then no. Let me see if I can't select that sketch while we're doing this on that plane. There's that. Okay, I can't is the conclusion. Bottom. Yeah, alright. I don't particularly like this, but it is where we're at. And shoot, what was the actual torus diameter? How do we define that? Alright, small ring ID plus inside wall thickness. And then wire 22 gauge diameter. Oh, and that said position outside and cut. Okay. Try this one more time. Repeat torus. We want to be on that plane. That guy. So this is that, right? Okay, well, that is that. And that is wire. And this is outside. Okay. There we go. And we did not clear the floor. We did not clear the floor, which is not wonderful. Because we should, this construction plane should only be up half the wire diameter. What's this? 1.5, so 1.7 divided by 2 plus 0.3 is 0.7, no, 0.85. 0.85 plus 3 is 1.15. Okay, so that is the correct number. This, huh. Yeah, the torus cleared last time. What is your actual number? Did I screw something up? Oh, okay, that was a +3. Okay. I did screw something up. We went the wrong direction. So when I was playing with these guys, so minus, and get rid of that, and +3 to come down. Okay. It's been a while since I've done this, in case you could not tell. It's been a few weeks. There we go, much better. Wake up, please, thank you. Alright, so this goes tangent. Okay, this is just my hole to exit. And we just called this 5 and 1.8, okay. And then we just extrude through. Oh, we did not extrude. I mean, we did extrude through, but we did the offsets at the very end, is what I was looking for. And the offsets are just 0.1 on all the inside stuff, right? Yeah, okay, cool. Alright. So, where is, just to save myself the hassle, there's that. Let's see. I guess it makes most sense to come out on this side, just assuming we're going to keep our orientation to make alignment easier. So, this is outside right side of capacitive insert. This was the torus plane. Mid plane, Z mid plane. More specifically, this is the ring layout. This is the capacitive insert. There we go. Rename, ring body, rename, wire insert, and keep on going. Project that, turn the body off, turn the other sketch off, centered, 1.8, 5, passive insert, distance to object, cut. That button? No, not that one. Let's see. Can I get a... Oh, yep, I can. I can get a point right here somehow. It looks like. I saw a point pop up. Oop, there we go. Cool. Alright. There's that, and then our offset. Actually, this is going to be the same for both. I can boundary fill this for both to save us ourselves times, which makes sense. So we are going to break everything is what we're going to do here. Huh. Or, we can just have the wire come out the bottom and not put this side thing in. I like that idea better. Okay. So we will delete these. And that is off by 0.1. Okay. And that's where we were at. So. Now that we have this, now we need to add the attachment point. So, actually, you know what? I think I will line this up at this point. Body, modify, align, because that makes it easier. Okay, modify, align. Hey, it does make it easier, but as always, we may be very much annoyed by future changes. Let's see. My only problem is that I guess it's fine. Okay. I was gonna say my only problem is that we're going to be awfully close to the wire. This wall is going to be awfully close to the wire at this point, but bottom of capacitive insert will survive. Project, okay. Toss that. Turn the body off. Turn that body off. Tangent. Centered. There. And this is only, okay, that's 2.8. That's not terrible. Okay, cool. I'm not unhappy with that. So we extrude this up to object that. I was thinking of offsetting it, but I guess we don't really need to. We'll come back up here and get a bottom of strut. Actually, all I need to is the bottom of strut. I don't need a sketch there yet. Of strut. Okay. Come back down here. Now I'll take my sketch on the bottom of strut. There we go. Always easier to click the whatchamacallit instead. The browser instead. Okay, yes, this is the wider side. So we go here. Grab those guys. Come down here, grab this guy, do that, turn the bodies off. This was ring inside attachment wall. I guess that's not a great name for it, but, and this is going to be the ring attachment. Okay. I guess I can't rename it while in a sketch. I guess. There's this. There. Not there. I really gotta check if there's a way to deselect the most recent select thing, because I always have to go back up and hit the toolbar when I accidentally do that. And let's see, circle. How many? I think we only need one. I don't think there's any reason to do more than one. 3, and this is 5.5. Yeah, I think I normally do 5.5. It's been a little while. There we go. And let's grab our center line here. all the way down here. And then we can grab a center line. That is not a line. Oh no, that is line. I thought I clicked a spline line, is what I thought I clicked. Center there. And quinky dink there. And quinky dink there. There. So we extrude by, let's say, 2. And then we extrude. Turn the body off really quick. Oh, we do not extrude by 2. We extrude by 2 with a join. There we go. And then we do that again with just the outside. So we can, actually, I take it back. There's no real reason to capture the bolt on the underside. So in that case, I will actually go ahead and thicken this up because we can afford it. Okay. And that is that. Again, a little bit flimsy, but in theory, it shouldn't really be getting too much abuse. And we are about to do the opposite one. The two-sided one, rather. Not really the opposite one, but... let's see. I'm actually not thinking about colors right now. I'm thinking about whether or not what I think I'm about to do is going to work. Hopefully it does. Otherwise, I'm going to look really silly. Where's black? Red, rather. Red. There we go. And let's see. All right, so there's the one-sided one done. Again, the wires are just going to come out of the bottom for this one. And also, again, this doesn't necessarily need to be all square. I'm just doing it because. All right, so what I think I'm going to do is this. Or, yeah, because otherwise it's going to forward propagate changes. Yes, correct. New component, select tools, not the origin. Is the origin actually on, or did I turn the origin on somewhere? No, I did not. Okay. Let's do both of these at the same time. Actually, I guess I won't. I guess I won't do both of them because I do want it to be nested just like the other one. So we'll do that. Come down here. Do the same thing with that guy, and hopefully this works the way I'm thinking about it. I think there's a workaround if it doesn't work, but we will burn that bridge when we get there. Mirror. Boo. Let's see. Actually, I could. So I've never done this before, but I was going to try mirroring the whatchamacallits. Huh. That does not quite line up, does it? Oh, no, that doesn't make sense. So, let me do this one first. Come down here. Like I said, never actually done this one before. What did I do here? Huh? Bodies? Bodies are visible. What'd I do? Oh, shoot me. Okay. That's what I did. Derp. I see what I did. What we do... Okay. Come back up here. Do the boundary fills here. Let me take a quick look because obviously that didn't line up the way I thought it did. We're on center on here, so this should be on center right here, which means that that point should map directly to that point when we flip this over. But it didn't. We had a gap. because that point, this line is on the inside of this, which is centered. Huh. And I just screwed that up, didn't I? Yeah, we did new body instead of new component. Because I was not paying attention. That's okay. New component, okay. Turn you off. Well, don't turn you off just yet, because I want to go ahead and boundary fill. Yeah, that guy. That guy, and new component. There we go. And now back to our shenanigans. So again, actually mirroring bodies is not something I normally do, but it 100% is valid in this point, it seems like to me. Huh. Huh. Did I derp something up? Back up, back up, back up. Where are you at? You're right there. What's my distance from here to here? 2.825, that's correct. So we are not actually on center? Is that what I'm finding out here? I was working on the impression that we were on center and I somehow fell off center. Bodies. Because if we were on center, I shouldn't have, you see how the blue overhangs here? So if I do this and take this inspect right here, this is going to be more than 2.85. Oh no, that does say 2.825. Why does it look different though? Why was, huh. Oh yeah, see? See, we're not on center. How do we not end up on center? I guess, let me see if this center is the same. Mirror, bodies, select that origin actually, turn that origin off. And actually, let me come in here and select that one specifically just to be sure. No, that, see, that's still not on center. Crazy. I mean, it's not on center because I had to align it. I get that much. Yeah, I did have to align it, so it would be off. Well, it should have aligned the component. So if it didn't align the component, then I cry. Let's see. All right, we can fix this. We can fix this in a simple way, a straightforward way to get us by, and that is to take this midplane. I want that face, thank you. And this is the ring midplane. And that is the X midplane. There we go. All right, so now we have an actual midplane. Mirror. That was not mirror. Mirror. Bodies. Over there. And that looks correct now. Let's double check the ring on the bottom. Ring on the bottom looks correct. And there we go. There is our double-sided one for that. We come back up here to here. Mirror that over the ring midplane. And that does look like it lines up correctly this time. Okay. Join. And actually, you can see the holes. If I come back over here to this. So I was a little concerned. Actually, I don't really need that. I was a little concerned with that mirror operation. You see how this hole right here? I was a little concerned that it might cut it, but because we're not transferring the operations. Normally we mirror operations. Because we're not doing that, it doesn't actually cut that out. It just does the solid body joins, which makes sense. So we are good then. So this is two-sided tray. Copy, paste, rename, duplicate tray for two-sided, rename, duplicate, what are we calling this again? Ring for two-sided. We already got that named. This is two-sided ring. I don't have to say mirror because we can see that's mirror in the toolbar. Two-sided tray. Okay. Now, let's see here. Two-sided ring. There we go. All right. Okay. Where I was going with this is we actually are going to come back here. Come back before that. Turn this back on. And I wanted to actually toss in my offsets really quick. -0.1, and these should forward propagate to the new guy. So if I take this inspect right here just to verify that wall to that wall, we are at 565, which sounds correct to me because we were at 545 before. So if we forward propagate, turn this guy off so I can see what I'm looking at, it should be 565. 565. There we go. Cool. So yep, forward propagated as expected. Everything appears to be lining up. Actually, I should also put an offset on the slide. So let's toss, actually back up here to make sure we're before the boundary fill. Do that, and I'll just toss it in with these guys, I think. Turn that body off really quick so I can get to that face easily enough. Turn that body back on. Okay. That obviously did not happen the way that I expected it to. -0.1. There we go. Much better. Okay, the one only problem, actually, I did not realize, is that... Oh no, it looks like we do somehow end up with the gap on that side. Okay, I'll take it. Let me... we did take our mirror, or our center plane. Alright, we took our center plane off of the... Huh, okay. Okay, let's undo that then. There we go. And I will just throw these in afterwards because I think something might have been wrong there, but I am not going to verify because it would just make me unhappy. Alright, so this is the two-sided ring walls, and then we need to come back in for... Turn that off. Let me set this to new offset really quick, which I forgot to on the first time. There we go. So we have 4.1. Turn that back on. There we go. Okay. And that is yellow and dark blue, which is correct. Okay. And now we just got to color things. And we will be done. Although I could also put an offset over here if I wanted to, or maybe on the struts. Yeah, maybe an offset on the struts. So we'll come back in here just to make sure they don't interfere with the... What do you mean the operation failed? Okay, fine. I will come back here then. Turn that on. Just make sure they don't interfere with the extrusion is what I was about to say. Huh. Why do you got a problem? Oh, I see. No, that should be fine because it's still attached up here. I was thinking that it was going to just... Okay, actually, if you're having a problem with that, we'll just extrude this instead. All right, minus 0.1. At what point does it give me the offset problem? Because I don't like this solution right now. Minus 0.1. Okay, from here. Really? Okay. Minus 0.1. Minus 0.1. Okay. Again, did not particularly like that solution, but that's where we're at right now. So... now, finally, we can finish this by adding colors to the other guys. Did I just drag that? I did just drag that. Dragging, as previously stated in many streams, should not be allowed in Fusion. You should not be able to drag objects. I know I take advantage of that from time to time, but I could always just hit the move command instead. Let's see. Plastic. And we'll go with like a blue. And let's make this brown. Okay, cool. All right, so there we are. So wires go in under here. These attach to extrusion. This attaches upwards to a nut. Again, a little bit fiddly, which I didn't particularly want, but, and also the, what do you call it? The smart material is not particularly desirable, but that's where we're at right now. The alternative was to change the design further, and I actually like the simplicity of this design, so I was not particularly interested in doing so. So that is where we're at. Where are you? Find in browser. There you are. And let's see. Inside strut print offset. And print offset strut and print offset. And this is rename ring slide print offset. Okay, there we go. I think that's everything. Two-sided tray, two-sided ring. Don't think I had any other things I added. Oh, I did. What is that? Oh, okay, we just never did the original. Rename, and this is the ring attachment. Alright, cool. Alright, oh, okay. This is, what do we call this guy here? There we go. I'm not gonna name that guy. Rename, wire print offset. Alright, let's hope that is everything. Alright, cool. That, with the exception of this position, which I do not think is relative, it looks like we now have a fully designed and fully documented design here. Fully designed and fully documented design. There we go. All right. Yeah, good job. So that's been that. I don't know if I really expected this to take the full hour and 15 minutes, or if I expected it to go a bit sooner. I know that I normally take about an hour to do pretty simple designs to begin with, so I'm not too surprised. Definitely could have been longer if I tried doing some other stuff with the mirroring on these components to get them into two-sided. Might have run into some problems, but we decided to take the easy path and saved a little bit of time potentially. Otherwise, yep, that is that. So I will go ahead and get these printed out for the arcade machine. I also need to get a design for the mech because, again, these are going to be used specifically for the mech combat inputs for LiteLike. And therefore I know I need 8 of the trays, but I need to see how they're going to end up being laid out to see whether or not I can use all the two-sided ones, which again I would prefer to use the two-sided ones because more stability, or if I need to use some one-sided ones because of space issues, save myself the extra ½ inches. So again, first thing first though is to design the mech. We still haven't done that. Again, I wasn't really sure whether or not I was going to do that on stream or whether or not I was going to just do that on the side because it is pretty tedious and it's going to take a while. And by tedious, I mean my biggest issue is that I still do not have a good grasp on what I want this mech to look like. I don't particularly like the kind of walking turret designs that stuff like MechWarrior has. I don't particularly like those designs. I like the more humanoid, traditional Gundam style mechs. That's my preferred. Although I could also do something more of a steampunk, and maybe not a steampunk is a bad word for it, but I don't know, is space punk a thing? I'm not sure. But the really junker style mech, I could do a junker style mech. I'd be cool with that design. Those ones sometimes are the mech style. Sometimes they, instead of being full on Gundam, will have like arms, but the arms are, hacksaws or something like that instead. So there's a lot of different options on how to make it look. I'm just not entirely sure. I still haven't, given enough consideration on what the theme of the game is. Obviously, with the scout bots, I made those way more shinier and way more futuristic looking than I was originally anticipating. If you look at the thumbnail, what episode was it? Let's see. I'm gonna pull it up over here. Where's my playlists? Playlists on the other screen. Where's LiteLike? There it is. Playlist. So the repair bot on part 7, on the 7th episode, I was kind of thinking something more like that. Obviously, my drawing's not the greatest, but if you look at its square and kind of very simplified shapes, So it has 2 very simplified arms. It has a square body. It has an antenna that you can't really see, but that's a very simple antenna as opposed to the Bluetooth antenna that, the wireless radio antenna style, the PCB wireless radio, I should say, style that our scout bots have. And then its thrusters, again, the scout bots have like these nice round thrusters on them, but the thrusters on this thing just look like, your traditional rocket cones. So again, originally I was thinking I was going to go more like that, but then we designed the scout bots, and the scout bots are nice and cute. So I don't know. They're also kind of interesting. So I'm waffling on how exactly the theme works in this game. Obviously, it should be more of a grimdark game because it's survival in space. So it should honestly be more towards that repair bot, that more simplified design. But I've already made the scout bots, which look reasonably futuristic, so I'm not so sure. And that is that. So if you're hanging out today, later on after, is it after lunchtime yet? Yeah, it's close enough to lunch. So after lunch, I'll probably go ahead and grab the arcade stick and hook it up and play some more Hollow Cure. And what was my other shoot? Oh, that's right. We'll see whether or not it actually gets done. So both this input array and the the Stream Deck, I was thinking about doing a masterclass, not a masterclass in the sense of the trade name that you may be familiar with on the internet, but a superclass rather for both of those guys to use for a variable expandable input array. That way we could have, in theory, multiple of these. So for example, this guy, well, for example, the game LiteLike, we only need 8 inputs, which is not terrible, and therefore we could handle that on a microprocessor. Right now the microprocessor is necessary because I don't feel like trying to figure out how to basically take the changes. So you'll recall, well, it's necessary for one because I'm not entirely sure how we're going to do a capacitive sensor without the microcontroller, because that's all set up through the microcontroller right now. Yeah, you know what, I'll just leave that much at that. I won't mention the other stuff. But the point being is that right now it's only 8, which we could get away with on specific microcontrollers, and we could also get away with a single shift register. If I'm recalling correctly, I'm pretty sure shift registers are 8 pins. Yeah, I'm pretty sure they're a 12-pin package, 1 pin for ground power, actually they might be 14 pins. It's been a while. Anyway, the point being is that for other games we could design, we may need more than 1 shift register to conserve pins. And even in this situation with the 8 pins, we could actually just do that straight off of a larger Arduino. I want to try getting it done with I would like to get it done with one of the AT Tinies, because I have them sitting around, and they're because this is just an input going into the joystick itself, the what do you call that, zero delay joystick USB encoder. Because it's going into that, I would kind of like to use the minimum technology possible, which again would be an AT Tiny as opposed to a full-on, let's say, micro or nano. But in the future, if we wanted to have more than 8 inputs, then that would require us to start daisy chaining these, what do you call them? I literally just said it a minute ago. Daisy chaining the serial, the PISOs, the parallel and serial outs. So since we're doing that, I would like to have the ability to, just with the AT Tiny, make that an independent system and have it do, not the AT Tiny specifically, but have a class that determines how many of these are daisy chained, probably via a dip switch, honestly is what it's going to end up with. So probably via a dip switch, figure out how many are chained, and then have the class handle shifting them all in, you know, creating an array to hold the values, shifting them all in, and then providing them to the main program. So that was my idea. So if I get all that coding done and prototyped, you know, so I can demonstrate it on a breadboard, then that would be the other stream today. Otherwise, we'll see what happens. Have not been doing much streaming over the past week. Again, as previously mentioned in the stream on Thursday. Yeah, stream on Thursday. Friday I had D&D, so did not stream. But the stream on Thursday, you know, just feeling a bit of ennui and a bit of lethargic because I have not been drinking coffee for the past week. This marks 1 week without coffee. Looking to go 2 weeks just to try to get fully detoxed, and then we'll go back to drinking some coffee. Drink coffee on and off just so that we do not have as bad of an backlash, and hopefully make the coffee more effective. And also I was spending a lot of money on coffee, so that is the other issue, or the other, I guess, imperative for this decision. So that is where we're at. I will go ahead and hit save on this file, and we will end the stream. So if you have been watching, thank you. And as always, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you next time.